Hello. So today I'm going to talk about this new project that I call Benchmarking Real-Time Reinforcement Learning. So the original motivation is that modern decision-making algorithms such as reinforcement learning rarely consider the exploding computational cost that is due to some of the models, such as deep learning. And in time-sensitive environment like self-driving car, robotics, embedded device, the inference time of your action or the training time is actually an essential component that's going to have a very big impact on performance. For example, if in a car the inference time for when to brake is delayed, that can have life-changing impact, basically. So historically, real-time control has been extremely used for safety and time-critical applications such as space navigation. And basically the idea in control theory and real-time control is that the stability of your control and how well it performs is going to be guaranteed if inference is done within a specified window of execution, basically. So what's interesting with reinforcement learning is that it relaxes some of the strong assumptions of control, and so potentially it enables to model more complex scenario, but in reinforcement learning, at least, we completely ignore the computational cost of all the algorithms that we use, which means that the algorithm are trained in like unrealistic setting where the state is frozen during action selection, and that can be problematic if we try to then deploy those algorithms later on. So the benchmark that I propose basically is to compare continuous control NRL and algorithm in a real-time setting. And practically what this means is that the time spent computing the next action is going to be time passing in the environment. So if you have a very slow algorithm, this is going to be reflected in the performance. And so we have two goals. The first one is to really analyze the performance trade-off between computationally complex and simple algorithms. So for example, linear model versus deep learning, or model free versus model based. We're going to try to piece out where each model is good or bad. And the second goal is kind of an exploratory analysis to analyze when real-time decision is complicated and which ingredients are missing from the current algorithm. So if you want to hear more about this, you can come and talk to me at my poster.